Hello, hello. Doing a quick mic check. Sorry about the delay on that. Making sure everything's working well, and then we'll get started. Got a few things to cover today. One is, of course, just how to support a model that's in multiple pieces. Once that's done, we'll move over to how to support more dimensionally accurate pieces that are used for molds or manufacturing, or in this case, like kind of miniature car parts. And then at the very end of the stream, we'll kind of move on to some events that are happening on that Lychee are doing, as well as some of our advertisers. Just waiting for 1 second, just make sure. Can anyone in the chat just let me know if the audio is coming well through, if it's loud enough, the video is coming in well? And if everything's going good, I will get started. All right, awesome, thank you. Audio's good, loud enough? I know some of the other ones I felt like it was a little quiet, so I want to make sure it's everyone can understand everything just fine. But all right, with that, let's get going. All right, the first thing I want to do is kind of how to do a model in multiple pieces. The first thing you're going to find when you load up this model, and depending on how the artist did it, you could find a pile like this, or you could find where it's already kind of pre-sorted for you. I put it in a pile like this just to kind of help what I go through from beginning to end. So the first thing on this one is, of course, figure out what you have on the plate. And usually with that one, it's easy enough just to kind of click and drag. If you click on the triangles, that's two-dimensional movement. And so I'll just kind of click on the yellow triangle, which is two-dimensional movement only on the z-axis. So that way you don't accidentally move stuff around the way you might not want to. So in this model, you can see it's not too many pieces, and they're all relatively kind of a little easy to support. So with that, we'll just kind of pick which one we want to start with and then go from there. What I want to start with on this one is usually the easiest pieces, and that's for this one's going to be the base. This base isn't too complex. It's got a little bit of a concave bottom on here versus a flat one. Sometimes the flat ones can be a little bit easier than one either with a logo or a texture on it, but I understand why some of the artists do it. So with that, first thing to do is just to put it a tilt. I've seen tilts of various angles where they're all the way or very shallow. There's some kind of pros and cons with each way of doing it. One con of doing it very, very high up on a really steep angle is when you go to place supports. Well, let me move it up a little bit. Usually move everything up about 5 millimeters off the build plate. We'll do 6 on this one. Actually, that's my z-axis. The downside of having it on this angle is your supports are usually going to end up all over the front of the model. Kind of down here where you can see them when you're done. Because if you just put them on the back, there's not going to be enough strength. So you're going to end up putting them across the entire front as well as the back. And so when this support is sitting down flat, you're going to see that damage. So what I like to do instead, even though it does require a little bit more material, I'll lay it down a little bit more flat, and depending on the size of your printer. This is a rather large printer I have selected, but let's select kind of a size that most people have, which is a 10-inch or so printer. On this one, you can kind of just see where you can get away with, and I can use this navigation box over here to kind of see. I can select these and hit V on my keyboard to turn them off so they're not in my way. Hit left, and I can even hit 0 on my keyboard to pull up the orthographic view. So now I'm getting a much kind of a straight view, so I can see how much I actually have for orientating this. And from here I can determine that proper angle to where I'm going to have enough room on the build plate, and I don't want to get it so close to the edge, because you get so close to the edge and you have to consider that kind of right here is the wall of the vat where the resin sits in. And there's not a lot of flexibility on the FEP between this build plate corner and the wall of the vat. Some printers have a lot more space where you can get closer, but it's best not to assume that you're going to have one of these very few printers with a much larger vat than the size of the build plate. So I like to stay away from it as much as within reason. So we could probably do a little bit more on that one. Maybe about right there where I'm not too far from either wall. And that will be the angle which I support. The next thing I have to worry about is this sharp angle. Of course, whenever there's a sharp angle like that, it's probably going to flatten out a little bit. You could throw some supports there to try to help, but it's really hard to make a really sharp angle like that not have some sort of damage. So with that, just make sure that the angle that's facing down is the back of the base. This base doesn't look like it has a back or front, but some of them do. So just make sure that the front of the base, meaning when the model is setting on it, is the one that's up in the air, and the back of the base, which you won't really see because it'll be behind it, is the one towards the build plate. So now from here we can, let's see if we can hollow. I don't think we can hollow this thing out. It's pretty thin. If it was flat across the back, we could hollow it out, but it looks like this was concaved to actually mitigate you needing to hollow it. So with that one, we will use one of my favorite tools, which is projection supports. That's under auto, and then start support projection. And this is a pro feature. And then from here, we can select my, whoops, I messed that one up. I can select my angle. And on this one, I'm just going to select this ring around it. Again, this is kind of why I like having a base that's flat if I can, because it makes this step much easier. We'll preview what I have here. I can kind of zoom in and see what's going on. So I can see that the support tips are really close to the edge, so much so that if I placed it, all the tips might actually be on the edge, which I don't want, because when those supports rip off, they might take out a bit of the top and leave this kind of like a sawtooth pattern, and I don't want that. So what I'm gonna do is go to the border, and I'm gonna change my offset here. This offset is how many millimeters it is from the edge. So it's set to 0.1, let's try 0.2. And that brought me in just a little bit closer. Let's just do about a half a step more. 2.5. All right, that's about right off of it. There's not gonna be much infill here. The infill would be the space in between the front and back row, just because this is really thin. So I'm not too worried about the infill. The next thing I can do is the Z influence. So you can see the spacing of these is all about the same. The spacing is set to 1.8 millimeters. I can change that, the way that's gonna work, by adjusting the Z infill. The higher this is, the support density is going to be pretty strong on the bottom. And as it goes higher on the Z axis, it's gonna get lower and lower and lower. So as we go up, we have less supports. I'm gonna turn that down. I don't use this too much. I know there's some people who really like to be really light on supports and really heavy on the bottom. I like the supports to kind of work with the model all the way up. And so I don't use that as much. The resin isn't too expensive for supports, for the benefit of having really good structural support all the way to the top. And this will play into when supporting engineering pieces as well. This same methodology that I'm using for this is really the same methodology I'm going to use for those parts. Those ones I might take a little bit more care and care a little bit less about how much resin I use supports, because then those ones, if it's a mold or something like that, it's a revenue generating item, or it's being dimensionally accurate, is so important. You care less about trying to save some resin on supports and more about that being successful. So from here, I'll click place supports, and now here I have this. This is a really good start where I've got supports are going to help this thing all the way up as it prints, and a really good density. The only thing I don't have is anything in the center. So what I can do now is place those in. And then so far, these are pro tools. If you don't have pro, you can manually do this. It just takes time. And the way the manual do it is just going to go in here and about the same density. And I can even show you what that looks like real quick. Let's delete this little row. I'll kind of even it out. Is you come in here with the supports, and I'm going to use a medium here. I use medium for the bottoms of everything. It doesn't matter how big the structure is, or how small it is. I found that 0.4 millimeters medium, if the density is right, it always works. So I'll come in here and turn on my mirror on the x-axis. Let's see. It might not work. I kind of rotated this thing around. Yeah, we can't use mirror on this one. So what I'll first do is find out where this white edge right here is right where I want it to be at the very first. And then I'm going to use the thickness of my support here as my guide. I'm going to make it just so there's enough of a gap in between each one. And I put that one a little over the side. And I'll just kind of follow that pattern all the way through. If you have mirror, it just makes it so you have to click less as often. And I'll just do that all the way through. And that's how you just manually do it. It just takes time, but it's absolutely doable. Let's undo that. Bring myself back There we go. All right, now let's show you another pro feature. And again, you can do all this manually. And this is the inline supports. What inline supports is if I click anywhere and then hold down shift, it will create a line from there to there. And I'm going to use that to support this base. I'm going to increase my density to about 4 millimeters because I don't need it to be as dense on the middle. Once these edge starts printing, that's really going to hold most of the weight. And then everything else, it's more just to really confirm it's going to, I'm not going to get sagging or layer peeling. From here, I'm going to offset my supports. And I'm going to use the grid pattern to help me out. So I want to go about halfway in between, and then I'm, 1, 2, 3, 4 away. So halfway in between, 1, 2, 3, 4. And we can even go at the top if we want, but that's not really necessary. And that way, and then I'll just kind of keep doing that across the board. Now this is a really big base, so this, even with this, it can take a while. But I'll just kind of keep doing that across the board until I'm done. And we'll pretend that those are done right now, as it gets a little boring to watch me do the same thing over and over again. But that's how I would get the supports down, so I know this base is going to print really, really well. Now finally, it's going to be bracing. Dimensionally accurate pieces or models, if it's too tall, you always need bracing. And for that, what I'll do is I'll go back to my top view, and I will use my orthographic, which is on right now. And then I'll just kind of select about where I think that these models, these supports probably need bracing. And it's probably about right there. And then I can just use the auto bracing. And that way I'm not bracing more than once and getting too much material used in bracing. I'm also not bracing supports that don't really need it. And that's kind of the quick and dirty way. The not so quick way that sometimes I'll do if it's like, let's say I'm doing a professional support job, I'll take the time to come in here and actually delete every other support, which can get a little bit crazy. And then I'll parent it by holding down Alt, and then just kind of doing every other one, like that, and then parent them down. And then once I'm done doing that one, when I brace, I'm going to manually brace just by doing this kind of a technique right here. This works really, really well. And I'm just bracing off of the one that I attached to and skipping about 2 to 3. And this type of bracing actually works really, really well, especially if there's parenting on the top to kind of act as that final support. What this does really well, it does a couple things for you. One, it makes sure that these models or these supports stay upright and straight while they're printing. The next thing it does is sometimes the supports will just stop printing. They'll be flat. What this will do is make sure that if it's flat, like let's say this fails to print, this structure will actually grab it and it'll continue printing, and there'll be enough structure to help it finish. And if this thing doesn't print all the way up to here, these things can still kind of pull onto it, these other ones, and this tip right here can still finish. Even if this one doesn't. So you're getting, the chance of success is really high, especially with this density, this 1.8 density. I use this particularly because if any one of these doesn't print, this gap right here isn't enough to ruin this print. So I could lose every other support tip and should still have a successful print. But when you add in bracing and parenting, the chances of that happening become really, really low. And so your success rate becomes high. Higher success rate means you're using less resin. So putting a little more resin into a higher success rate, I think in the end is a positive and actually helps you save resin and time. And so with that, that's the end of the base. So we'll move on to the other part. And I've got quite a few things in here. Let's see, which one do I want to choose? I'm not gonna have time to do all of them. There's one in particular. I think the upper legs will be a good one. All right. Maybe if we have time, we can do a couple more of these. All right, so kind of the same thing. We're left with this part, and the good thing about models like this one, if you know how to do minis, these are easier to support than a mini, hands down, because the amount of craziness going on is usually reduced by the cuts. You have spaces you can put supports, and it'll be unnoticeable when the model's assembled. So all those places are the keys. You can put as many supports on these keys and you'll never notice it because when the model's fully assembled, they're hidden. But there's something to consider even still with that one. And I can use this nice tool, rotate, and there's rotate on the plate to kind of quickly showcase how I can move this model around real quick. The thing to consider is supports that can still be seen that aren't on the model. If I rotated it like this one, you can see I'd have to put supports. We'll lift it off the build plate just to make it easier to visualize. I'm still gonna have to put supports on most of the objects that are, they're highlighted. And that's gonna be visible because when I'm looking at this model, I'm looking down on it, and mostly down from the front. So this view right here, if this was flipped, would be kind of the way I would look at this model. So what I would do is, instead, I would rotate this model the other direction, like this. And that way, when all the support is on it, it's not noticeable because I'm not looking up from the model like that when it's on display. And so another thing I like to do, and this one's really easy, is I like to go to this view, hit bottom, and make sure orthographic is on, which it is. And I can get an idea of where the yellow is, where I'm gonna probably have to have supports. That's not always true, and it's not always not true, but it's a good indication. So what I can do from here is I can kind of rotate the model. And what I'm trying to do right here is I'm actually trying to balance between surfaces that are non-noticeable, surfaces that aren't. Let's say I was going to have some extra pieces that we're going to bolt on here. I don't think this model does, but let's just pretend there's like a holster or something went there. Well, that's going to be covered up, so I could use that as a place to prioritize putting supports there. And if this side wasn't, then I would kind of keep that side up, because anything that's facing up and away from the build plate is going to be really high quality. Anything facing down is going to be much lower quality. So because this model is pretty easy, we're just going to, I'm going to go bottom again. We're going to just center it, kind of like that. And that's worked well enough. Now from here, there's something that I noticed with this model, which is the next step, which would be hollowing before I go to support it, is that this model, if you zoom in, you'll see, I don't know how well you can see it on the live stream, but there's all these lines in it. And what this means is this model isn't fully booled. There's a lot of different models kind of smashed together to make this model. And so when I go to hollow it, it's not going to be the best hollowing because each one of these is going to hollow independently because the slicer doesn't know what's really what. So if I'll show you what that looks like. Let's go to a less thickness and we'll apply the hollow. You can see that's not really much hollowed. Some places are hollowed better than others because there's less interlocking mesh, and some places there's not really much hollowing at all. So the way this model is set right here, you really couldn't hollow it. If you did, you could hollow like this one, but you're gonna have to use block like holes, and you're gonna have to put these holes through the model, and all the way through it. And if I go to the interior view, you can kind of get an idea of what's going on here. And this hole, I would have to kind of push all the way through it to make a gap. But there's still gonna be individual chambers. You can even come in here and put holes down in here to try to open up these chambers to to kind of cut through them. It's a little messy. You could do it using these views, but this isn't exportable as an STL. It's red, which means these empty spaces will only be there if you slice this file using Lychee Slicer. So there's another way to kind of manage this, and this is leaving out of Lychee Slicer just for a moment. And I've already done this work, so you don't have to sit here and watch it, but let's open up NetFab. So with this tool, what I've done is I've exported the model as an STL. I've then loaded it into NetFab, and I ran a repair script on it, which I've already done because it takes a long time. And then when I run the repair, I run the 11 action. This will make it so this object can be booled, and then I'll click on the object and click on this bool part, and then I'll have an option down here. I could do it again, I guess, but I won't because it's already been done. This will unify all the mesh into a single shell, and then I can export it as a new STL, which I've already done already. So let me go show you what that looks like. I think it's right here, legs boolean. So this is the one where I have already, make sure that's working, there we go. Where I've already done that to it. So now if I come in here and I hollow this out, which I've already done, you'll see that I have a complete exterior shell, and now I can hollow it out completely. So NetFab is a free tool. It's free, but there's you can use it for free forever. Technically it's paid, but the makers of it don't care. And for something like that, it's a good tool to use. And from here, and this is a rare thing. Most models are ready to hollow and stuff like that. So this is just if you happen to run into a model that looks like that. All right, so now if I place my drain holes, they'll go all the way through, and I can check on that they're all the way through. Oh, no, they weren't. So let's go through and push those through, make sure that they're going to drain. And one thing I like to do is I like to make sure the drain holes are towards the top. This is because when well, you have to have two drain holes, one at the bottom to prevent a suction cup, but one's at the top as well. So that way the model will drain all the resin when it's hanging upside down, ready for you to remove it. And real quick on a chat, yeah, to say I thought the red holes were saying it wasn't going to work as a hole. No, it will still work if you slice it within Lychee. It just won't work if you try to export it as a .stl, because when you export it as a .stl, the entire model is actually meshed out, and the holes and the interior now become a part of the model. Instead of right now, the hollowing and the holes are code. They're not actually there in the mesh, which makes it really easy for the slicer to work with it, because the more polygons you have in your mesh, the more difficult it is for the slicer or your program, and also the larger the file sizes. So doing everything in code is definitely the way to do it. And then you don't care if it's red or not. And the next thing is we need to make sure there's no suction cups. So we'll go through and place these down at the bottom. These ones don't need to be very big. I just want it to start at the lowest point. And same thing, I can look at it and make sure that it's going all the way through, which it is not. And there's, I guess there's two ways to do this. I can use the interior view, which is always nice, to kind of just puncture it through. One thing you don't get is if it's a mesh hollowing versus a code hollowing, you can't use the 3D view, because there is, if this was all mesh, the interior exterior button here is code based. It's not structure based. So that simply will not work if this has been exported already as a 3D hollowed object. All right, and then we'll want to put a few more of these here. And I don't want to keep doing that, so I'm just going to Control C and Control V, and I can paste the parameters of the holes that I've already have. I don't have to keep messing with them. All right, and that, we can even make these ones a little bit bigger, since they're not. They're pretty good sized keyhole there. And I'll put another one on this side as well. I just really want to make sure this thing is really easy to clean, and it drains really, really well when I'm cleaning it. And this is an important step to do first before you start supporting, because you want to put your supports around the holes. All right, so now we are prepared for the hollowing and the drainage and suction cup removal. And we can do a quick suction cup search just to confirm. Sorry, these are pro features on some of these ones. Now right here you can see that I've got a suction cup that I missed. This is a suction cup that is geometry. And so even though you wouldn't do this, because this is the keyhole you need, if I were to put a blocker here, which normally prevents hollowing from happening, you'll see what happens when I update it. There's the blocker there. So where that cylinder is, it prevented the hollowing. But where this was at, it didn't. And that's because this isn't a 3D hollowing, or a code-based hollowing. This is structure of the model, so it cannot affect it. So we wouldn't want to even try to block that out there. Instead, what we would do is grab another hole and just place it right there, just to keep that key, excuse me, sorry 1 second. Just to prevent that from being a suction cup right there. All right, we can go back to our hollowing, run another search, and the suction cup is gone. This little tiny one here we don't care about. It's too little. It's not going to cause any issues at all. All right, so now we can move on to the real reason why you're here, which is supporting. So with that, let's get started. On this one, I won't use projection support on this. There's too much angles and geometry. But I'm going to use the same methods I used on the base. I'm looking for flat surfaces, and I'm looking for edges, because the edges are what's going to keep this model where once you're done printing it, it's going to assemble without any lines or gaps that have to be filled in later with putty or anything. So I'm going to use my medium because I'm on a part where I really don't care about support damage. And first thing I'm going to start with is just looking for the first thing to print, which is these keys. These keys don't matter, whether or not I hit F on the keyboard to do that, by the way. Anywhere your mouse as you hit F, that's where you're going to zoom in. And I'm just going to make sure these keys print really, really well. Because also this key turns into a really big support if it's really sound. And that's a big support surface right there on that one. So I really want this key, not only do I want it to print well, I don't want it to move around or shift during the print. So I'm going to put a couple supports to keep it anchored down, or to keep those first layers printing, these first layers. But I'm also going to put enough in here to keep it so that when this whole thing's floating in the air like this, it's not going to wobble around and wiggle, because that's where I'm going to get layer lines or failures and all sorts of problems. Next thing I'm going to do is just kind of go around and do the same thing, but on the edges, where I'm just going to go through and find these edges that stick out like this. And of course, you know, the lower that line is, that's the one that's going to print first. And so, you know, you can do something like that one, but of course you end up making a wall. We don't want walls. So we'll delete those two, and instead I'll hold down Alt, and I'll parent them. And that way I'm not using as much resin, and I'm not making a wall. I don't need this many right here, but this is the part that prints first. So I really want to make sure it's going to be a really high quality model. If I held down Shift and Alt, it will repeat this one, so I don't have to keep doing it over and over again. And then I can just keep going like that. And just kind of keep going around doing the same thing. I can even kind of skip a couple like this and then come back over and add in the parenting after the fact like that. So there's a couple ways to do this, and you can make it kind of quick. And also make sure that when you're done, it's nice and kind of clean down here, clean looking. Once you're done going around the edges, you just basically do the same thing all the way around the entire edge. And once you kind of get good at it, you can do it pretty fast, where it's really not a lot of work. And then, and also when you parent, you always parent to the one that's above it, not the one that's below it. That will be much more structurally sound than going above it, or that's the one below it. And if I hold down Alt, I don't even have to keep clicking Alt. I can literally just hold down Alt, oops, and just kind of keep going. And then something like this one, I can even cheat and just put all the way through it to do my bracing and my parenting in a single go. And now we'll just kind of parent those out. Oops, moving a little too fast. And that touches that one, so we're good. Parent that one out, and now that leg is done. And as we go up, this is another flat edge right here. I'm a little worried about this point. So, and I don't need the 0.4 anymore. This is gonna really hold this whole shape right here really well. There's a lot of structure there. So I can go to something like a medium light, which for me is, you know, from 0.4 to 0.35, or a light that's 0.3. Probably this one, a light's good enough, because this is a downward triangle. And so what I don't want is to have one support here. I actually want to have 3. And since these ones are on the outside, I'll even go to like a really, really light one, like my ultralight, which is 0.24. 0.24 is pretty much the smallest I use for anything that I want to hold weight. And this is holding, it's not really holding weight as much of as keeping this weight from shifting until the rest of the model prints. You can see what that looks like here. I don't want this to move around. And this, honestly, I don't think is enough, but that's enough to at least get this point going exactly where it needs to go in 3D space. So as we build upon it, we don't end up with like a layer line up here when these two merged and they're off a little bit. And so with that one, we'll just kind of keep going on my, a couple more on the light supports to follow this line up to make sure that this is gonna stay. Now I don't like this right here because it's off on an angle, and this is actually more contact point than a 0.3. So I can move this around. If I've got premium, I can move around the base and just find out where it's coming off at the angle I want. I can even do that. If you don't have that, if you don't have premium, you can just drag the bottom and move it around, and then drag the tip and move it around, get the same result. It won't look quite as pretty, but it'll get you the same result. And then do the same thing up here. And that right there is going to be structurally sound enough. Another way to brace is if I just select these two and I click on my bracing, it will brace between the third one, the one in the middle, and I don't have as much bracing as if I just like, let's select these two right here and hit bracing. You'll get a little bit more higher density than the ones that are separate from the two. So now that leg is pretty much done on that side. This should print all the way up. I'm not really worried about this interior line right here, but just in case, we could say, well, this is an interior of the object, meaning you're not going to see it too much. It's on the inside of the legs. On the back, you're going to see even less. So if I were to prioritize this seam right here, it's really not going to be very noticeable. So I could start here and just hold down Shift to do a line support, which will follow that line, and I can just kind of add a little extra support on the way up, just to be sure. And these are ultralight. I probably wouldn't do ultralight, I'd probably do light. If I'm gonna put a support tip there, I at least wanna make sure it's gonna do something. And the light is gonna do a better job than the ultralight. Oops. And that will keep those kind of structurally sound. The next thing is these are a little bit in line right here. I can come over here and I can actually just kind of, whoops, move them around if I want to, and offer them a little bit more, make them a little wider. That way they will hold themselves from doing this, and I'll have more of a three-dimensional shape. Or you can just hold down Alt, double click, and then you'll have a little bit of more bracing that I can then like parent to that one. And that will kind of keep this whole thing from turning over to the side. And as for the rest of the leg, we'd basically just do the same all the way up, and then this leg would be done as far as the outside's concerned. You don't want to forget about the key. This key right here needs to be dimensionally accurate. It needs to be the correct depth and the correct size, or when you go to put the upper body on, it won't fit. So what we can do on that one is we can go to our interior part right here, and there's the key right here. We want to make sure this prints properly, and we got a big island right here. So on those ones I use interior pillars, which is just 1.5 tip diameter, 1.5 tip. What it looks like is a pillar, where the entire thing is the same shape. And on this one I'll just go through and place them like that. So that way it will keep that key printing. The rest about it, I don't really care this top surface, and I'm not too worried about printing. But if I was, I could just go over here and put a couple pillars around the holes, just to make sure they're going to stay flat, and that way this top part stays nice and flat, so I get a good connection with the chest when it comes on. If I were to go to the torso, and I don't have time to print the whole thing, but it's just kind of an idea of what we want to make sure. We want to make sure that this key and this triangle right here, that it fits onto that the legs really, really well, because the seam is going to be really noticeable when it's done. And here's kind of like one of those gotchas. If we printed it like this would be a perfect seam because it's up. And so when we put that chest on those legs, it would just seam really perfectly. But then we have to put supports all over the upper body. If this was cut in a way where maybe this pad was separate, you could maybe get away with doing that, because this pad you'd print the other orientation, and by the time you assembled it, it would all be missing. But on that one, what I would end up doing is actually leaning it more back in order to preserve this this dip right here. This dip right here makes this model a little bit harder to support, but not impossible. Because really what you want to do, let's go back to my side view. I normally wouldn't lean, I would try to do it more up like that normally, because that way I only have to put supports on the bottom. This is all going to be mostly self-printing, but I really worry about this right here. What I may even do if this was mine is I would actually print one version like this to see how well I could get that to print, and I would print another version that was more like that, in hopes to get that thing to print well. Of course, putting a lot more supports on the back of the model, creating some more damage. So that's what, and then it's the same thing as I did on the other one. I'm going to come through here with the, I'll hollow it, put my suction, make sure there's no suction cups, and then just start supporting, following these lines as I go around, just making sure that I'm basically going through and doing the outside first and then filling in the inside. Sometimes I'll do is I'll go around and I will place these kind of like this at the density I want. Then I'll go back through and I'll delete every other one. And then just holding down Alt, just kind of go through and replace the ones that I deleted once I got the density right, the interval right. And it's the same thing. At that point, it's mostly just rinse and repeat. Like I said, supporting these types of models is really, really easy as long as you're not afraid to put enough supports on where when it's all done, these pieces are going to assemble together really, really well without gaps and holes and stuff like that. And that's going to feed right into, into doing more stuff that's engineering type work, or let's say this guy right here, a mold. This isn't the best mold. I'm not sure it would really print very well given some of the geometry issues, but I wanted to show how something like a mold can be different than anything else. And what makes molds different is that we actually don't care about the exterior shape. We don't care what happens to it. We only care about the interior shape. And so what we do on that one is mostly, well, a couple things. One, when we hollow it, we're not going to use 2D hollowing on molds, or 3D hollowing on molds. You're going to use 2D hollowing. And the reason for this one is because you want this lattice structure that's going to come through and actually just kind of create an even fill and infill and supporting throughout it. The reason for that being is usually molds have, not particularly this one, but usually molds have a lot of flat surfaces on them. And if you have a place where you have really thin walls or thick walls, or you've got like a lot of internal support structure and then a place where you don't, you might get a layer line there, or a little bit of blooming, or just slightly different way that the printer is going to work with that hollowing. When you use a lattice structure, it's going to be a lot more consistent throughout the entire mold, and you won't see some of those layer lines or some of the other issues you'd get. With lattice, you can't export that as a 3D structure at all, so it has to be done within the printer, and you still have to make sure that you have the holes. When you place a hole, it will disrupt the lattice structure when it's printing. So if I put it where it needs to go, where this intersects in the lattice, it of course won't actually create that. It's hard to see because it's black on black. But in this area right here, this lattice structure won't, the bottom of it won't print, but as it goes up on the first, that first contact where it makes, it's going to start printing, and the rest of it's going to be just fine. So don't worry about that one if you're doing molds. Next thing about molds is mostly they're going to be printed straight up and down. Because again, we don't care about this bottom surface. We don't care about it at all. We only care about the interior. And this is where projection supports come in. You're just going to hit this bottom on projection support using a really high density, like I kind of showed before, and you're just going to load this thing up. Because again, you do not care about it. One thing to keep in, well, let's move out that one. I'll get back what I was going to say in a second. Where's all right, let's bring these in. Here's a kind of example of some ones that I supported a little earlier that are kind of like little car parts. I wouldn't say these are necessarily engineering parts, but they're parts that have to assemble afterwards. They're going to have some pretty high tolerances. And so one of them is this rim right here. With this rim, I would print it like this, where it's flat, which I know you're told not to do a lot. Angles, 45-degree angles, stuff like that. The reason why I do it like this one is because, one, all this structure inside of it, and I put a lot of supports in here because I want to make sure that any part that's flat is supported, and then I've got some extra supports coming down to the kind of going down, and then this support's going to kind of bring up the rest as it goes up. But the reason why I would print this one like this one instead of at a 45 is because the reason why we don't like 45 is shallow angles. This angle right here is the one I'm worried about. If this angle is shallow at any point, we're going to see really bad stepping, and this print won't turn out very well. If I were to, let's just delete the supports so I can angle it. Can I show you what I'm talking about? If I were to angle it, I'm going to have differences of angle, and the angle is from the build plate. So from the build plate's perspective is the angle we care about. I'm going to have a shallow angle here and a steep angle, and a shallow angle here actually. Actually kind of two shallow angles. And again, the shallow angle is anything from 0 and 90. 45 is a better angle, but as you get closer to 90 or 0, those ones up here, that's where we really care about that shallow angle, and you're going to start seeing layer lines. Now that rule of trying to find the perfect angle, it only works if your model is pretty basic. As soon as your model has a lot of angles and stuff all over, you just forget about it entirely. It doesn't matter. You support the thing the way it's going to be easiest to support, and it's going to require the least amount of supports to do it, or the least amount of supports on surfaces that are visible when you do it. If something like this one, this whole back of it's going to not be viewable. So what I care about most is these angles and avoiding shallow angles. And the only way to avoid a shallow angle on this one is actually to print it flat on the build plate. Now, this is what I was going to say earlier. When you print something flat on the build plate and you have this flat surface right here, you're going to get pillowing. And pillowing is when you it's basically when the resin is printing. Let's move this thing down. If I'm printing a single layer like this, you can see it's really, really thin. But this still has to print. And as this prints, you're going to have the light's going to go through, and it's going to cure a little bit of resin around and underneath it. And as you continue printing, of course, it's going to print down like this. As I continue print, the resin is going to continue to penetrate down through this layer being printed to the resin stuck under here. And it's going to, chicken skin. Yeah, it's gonna bubble it out. It's gonna look bad. It's even actually gonna build up around your support tips and give them, when they break off, you'll see like they'll way more damage than you've seen before. And you'll be like, what's going on here? I've used these type before all over. It's never been an issue, but now it is. And I have a really good picture of this to show it. Give me one. Actually, I can show that right here. 1 second. Of what this looks like, a comparison of what you're trying to avoid. So this is a print that I did. If you can, should be shown okay. Yeah, this is a print that I did where these models were printed exactly the same. Same orientation, same lift speed, same 3-second light off delay. The difference was, of course, it was the resin. One resin, this one doesn't have as much light penetration. It's a more accurate resin. There's more pigment in it than this one. So this one, even though it doesn't really show any pillowing, there's still some layer lifting. And layer lifting is also another cause of printing flat. This is just where, that very thin layer doesn't have a support underneath it, so it just kind of tears. And then, it eventually corrects itself, but that's what it looks like. That would be fixed with like a 10-second flat sand. And this would be perfect. This, again, both of these resins are also calibrated to dimensional accuracy. This is just a resin that doesn't deal well with, small layer height. So both these are printed at 30 UM, and doesn't do well with this one. And these were only angled about maybe 5 degrees, and I did that intentionally. And so this is what you get from it. You get that kind of a texture where it's really bubbled out. It's just not. It's not the best. So that's what you want to try to avoid that with a model you care about the bottom. But if you don't care about the bottom, it can be flat sanded. Then this is a trivial issue, and you can completely ignore that it's even there. And so this is going to cause that issue, depending on the resin I'm using, better or worse. But again, this is a part that can be flat sanded without ever noticing it. And so we don't care about that. We care about this right here, because that's the one that's going to be facing us. The radiator is the same issue. It's going to have the exact same thing right here. I printed a flat. This, we're going to need a little bit of flat sanding. This is enough angle, everything else is enough angle. But the part we care about the most on this radiator is actually this texture right here, the front of it. If I were to put this on an angle, let's say like this, I'm going to see layered lines. I'm going to see bumping, unless I find that perfect, angle where my z-axis and my pixel density are like perfectly aligned. I'm going to have stepping on it. So these bumps right here aren't enough to cause any issues. And so trying to get flat up, this is going to have a really sharp, really clean finish to it when you're looking at it from the model. Right here on this chair, same thing. I wanted enough supports on the bottom. So I want to make sure these are basically keys. I want to make sure that they're going to print and that I'm holding those lines all the way up through, because all I care about is when the seat goes into the model, it fits perfectly. And I want to make sure that this part of the seat right here, this is a not very visible part. And so I kind of used thicker supports and then thinner supports as I went up. So that way I'm still keeping that model from shifting and moving during the print, trying to prevent layer lines or failure. I don't think I'll get failure with the amount I have on the bottom, but without these here, I might get some layer lines and some shifting. And the next thing is suction cup. This model, if I push it more towards the back, because the back is also a surface we don't care about, but I'll show you what happens if I lean this thing towards the back, like this. If I try to preserve this front and lean it towards the back right here, I end up with a suction cup. And the suction cup is right here. And so until these keys right here are, not only do they show, but they're actually big enough for resin and air to flow through, which probably won't happen until, maybe like right there. Anything below this is going to have layer lines. It might explode. It might fail. it's going to be an awful, awful print. And so what we want to do is prevent that suction cup. And since it's a geometry suction cup, we couldn't fix it unless we put a hole in the model. And if, maybe you could put a hole in the model if there's going to be something here in the end, but for this one, I don't think that's the case. And so that's why we wanted to make sure that even though it may not be the best orientation for the final design, it's the best for preventing some of those major issues that are going to keep it from working at all. All right, I think that's it for Lychee Slicer, unless there's any questions about anything I've gone over. Just looking at the chat, see if anyone all right. If there's not any questions on supporting for multiple objects or for dimensional accuracy and engineering parts, can move on to the last thing, which is just what we've got going on here in the future. Real quick, this cat girl model right here, which you kind of got to see some of it, but not all of it. This model is if you're a pro member of Lychee Slicer, you can get it if you go on our Discord. And I can show you that real quick. So if you're on our Discord real quick, and you link your Discord to Lychee Slicer, and you go to the pro channel, which is if you're a pro member, and you click on this pin right here, you can download that model for free and a bunch of other ones we had for our Thanksgiving pack that are still available right now. I don't know how much longer those will be up. So if you are a pro member, make sure you hop on our Discord, link your Lychee account, click on that pin, and make sure you get that model, because this is one you can get and print yourself right now if you want. All right. All right, last thing is some kind of things that are going on. There's a couple promos happening. Any hope of audio, everything working perfectly? Sorry, there's a question here. It says, any hope of auto, everything? Oh, auto supports. If you're saying, is there any hope of auto supports working perfectly? Is that if that's the question? I'll pretend it is. I believe so. There's about a minute delay between when I ask a question and when you guys actually see it. So auto supports are really difficult. Same with auto orientation. They're difficult to do because there's a couple problems. What we're really talking about here is AI, artificial intelligence, to orientate and support that model. And there's a couple problems with that one. You can't build an AI unless you train it. You can't train an AI unless you have tens, thousands, hundreds of thousands of objectively correct things to train it on. And so you'd have to create a library of objectively correct orientation and supporting. And I think orientation and supporting are very subjective. And so that's difficult. But I'd say that's probably the bigger one issue. There is other ways to get around that. If you go to the high-end engineering where they solve it, is kind of we just create a lattice structure that can really kind of go through and kind of just pull on everything, and it's up to you to find the best orientation. Those have been the best I've seen so far. And but yeah, as far as perfect audio orientation, I think we're really far away from that. It's also to create good AI is really resource intensive, time intensive, in human as well as systems. And so, the investment to do that would be pretty high. And in the hobbyist world, I don't see that level of investment coming in the near future, but I could be wrong on that one. All right. So giveaway starting on Monday, the 18th, it's going to be on our Instagram. We're going to be doing a giveaway where every day, starting on the 18th, but basically from the Monday through Friday, we'll be announcing what giveaway that will be and what you have to do to enter into it. Every day is going to kind of be a different vendor, starting with Monday, the 18th will be frozen. And so, there's going to be a wash and cure station. One person can win 3 bottles of resin, one person can win 2 bottles of resin. And that's what these are, individual prizes. And then, of course, Lychee will be giving away free Lychee Slicer bundle licenses. And we'll be doing the bundle licenses every day, Monday through Friday. Anycubic will be day 2. Sorry, I don't have all the artwork. We'll have the rest of everything when we announce it through next week. So sorry, Anycubic, working on it. They'll be doing Cobra 2 and filaments, as well as and we'll be doing the Lychee Slicer bundle. Tritech will be giving away lots of resins. So definitely keep on mind that one. They have some fantastic resins, some of my favorite. Elegoo is going to be giving away a Mars 4 Ultra, the Mercury Plus Wash and Cure, some resin, as well as Lychee Slicer, the licenses. And the last day is Apex Makers giving away their X2, as well as the Lychee Slicer bundle licenses. And then coming up here pretty quick, we're doing another promo on Lychee Slicer with a 20% discount for the yearly promo. And sorry to say, unfortunately, again, this is for new subscribers to Lychee Slicer to the year with using that code. This isn't live yet. We'll make more announcements on when it will be live. All right, and that's all I had for the show today. Is there any more questions? And these questions could be about anything at this point, just while we kind of eat up the last couple minutes of the stream. I can say I kind of dressed up today for the Christmas themed special. All right. If there's no more questions, we will. I guess I'll end the live stream a little bit short, 5 minutes. But yeah, thank you as well, Jerry. And with that, I guess thank you for watching and have a good day.